Hi you guys, I hope that all of you are doing well. Please make sure that before you watch this video, you have watched the other videos that I have posted for this lesson in your Math 7 or your Math 7 Honors course in Canvas. So let's go ahead and get started. This first question says, which pair of figures below are congruent? Now, when we are talking about two shapes that are congruent, that means that the shapes are exactly the same shape, exactly the same size, their angles are all the same, and their side lengths are the same. So in order for two pairs of figures to be congruent, they have to be exactly the same. So when we look at this first set of shapes, this is 1, 2, 3 by 1, 2, 3, 4. This is a 3 by 4. And this other rectangle is a 1, 2, 3, 4 by 1, 2, 3, 4. So we have a 3 by 4 and we have a 4 by 4, and those are not exactly the same. So we would say no, they are not congruent. Okay, then let's go ahead and look at these two triangles here. The base of this triangle is 2, and then the height we can see is also 2, and then the base of this triangle right here we can see is 1, 2, 3, 4, and then we have the height, which is 1, 2, 3, 4. So we would say no, these are not congruent. Okay, now let's look at the next pair of shapes. It looks like we have this part right here, which is a 3. Okay, so this side is 3. Oh, and it looks like this right here is 3. And then we have a 1, 2, 3, 4. And this is a 1, 2, 3, 4. So these are exactly the same. Even though they're flipped in different directions, they are exactly the same shape. They're the same size. If we were to check the measures of their angles, they would all be equal. We already checked the side lengths. This one was a 3, and this one was a 3, and this one was a 4, and this one was a 4. So their side lengths are the same. We would say yes, these two are congruent. They are exactly the same shape and size. Okay, and then obviously these circles are not congruent. We would say no. Okay, so let's just go ahead and look at another example here. Obviously, when we look at these two circles, this is more like a oval, and this is a circle. So when it says, are they congruent, we would say no. And then, are they similar? We would say also no. Okay, similar means that they are the same shape, but different size. And when we talk about two pairs of figures that are similar, their side lengths are proportional. Okay, so let's go ahead and look at this next one. This triangle is 1 and the height is 1. Okay, and this is 2 and the height is 2. So if we have a 1 over 1 and we set that equal to a 2 over 2 and we cross multiply to see if those are proportional, remember that if the cross products equal each other, we could say this is a proportional relationship. So 2 times 1 is 2, 1 times 2 is 2, 2 does equal 2. So these are the same shape, they're not the same size, but the side lengths are proportional. So they are not congruent, but they are similar. Okay, let's go ahead and look at these two rectangles here. This is a 1 by 4. And this is a 2 by 2. So let's go ahead and set up a proportion here. 4 over 1, is that equal to 2 over 2? Well, when we cross multiply here, 2 times 4 is 8, 1 times 2 is 2. These side lengths are not proportional. Also, these shapes are not the same shape and same size. So they're not congruent. They are also not similar. Okay, and then the last set of shapes, we have a 2, 1, 1, 3, 1, 4. So let's see. We have a 1, 1, 2, 4, 1, 3. those are congruent. Okay, and then when we talk about similar, similar means that the figures have the same shape but not the same size. Similar figures are not congruent. So we would say no, these are not similar. Okay, so let's look at an example like question 6 that says triangle ABC and triangle PQR are similar. I wanted to do that in yellow. Sorry about that. So they're similar. That means that they are the same shape but not the same size. And to tell whether the two triangles are similar or not, we can set up a proportion. Okay, so let's just do that really quick. Let's do 7 over 8. And remember, when you're doing this, you have to keep the ratio the same, which means we would have to do 49 over 56. Okay, and we can see that these are proportional because if I times both of these by 7, that's how we get 49 over 56. Or if we were to cross multiply here, we would see that the cross products do equal each other. 56 times 7 is 392, and 8 times 49 is also 392. Okay, so we are supposed to find the missing side length. So in order to do that, we're going to set up a proportion, because remember we know that because they're similar, the sides are proportional. So let's call this one that we don't know, let's just call this an X. And to set up a proportion, we're obviously going to have to use this side, which means we're going to have to use this side, right? Because that's the one that corresponds. And then let's go ahead and use this side and this side. Okay, so what my proportion is going to look like is x over 7 equal to 35 over 49. Okay, now from there, to solve for the x, we are going to cross multiply. So 49 times x is 49x, and then 7 times 35. Okay, and then when we solve for the x here by dividing by 49 on both sides, we get x equals 5. Okay, and we can see that to get from this side to this side, we had to times by 7. To get from this side to this side, we had to times by 7. And so 5 does make sense. 5 times 7 does give us 35. Okay, so let's go ahead and look at another one here. It tells us that these triangles are similar, so we don't need to check that this time. We are just going to go with the fact that the problem told us they're similar. So that means that they're the same shape, but different sizes, and that also means that the side lengths are proportional. Okay, the one we don't know here is this one. So in order to set up our proportion, we're going to use this one, and the one that corresponds with that one is DF. Okay, so AC and DF. Those are the corresponding sides on this shape. And then let's go ahead and also use this one, BC and EF. Okay, so when we set up our proportion, remember we have to make sure that we keep our corresponding sides in the appropriate places in our proportion. So I'm going to do x over 7. So I'm going to do this side over this side. So I need to do this side over this side. Okay? We need to set up a proportion with corresponding sides. And then from there, we would just cross multiply. So 49 times x is 49x. 7 times 35. Interesting. This looks just like the last one, doesn't it? And then we would divide by 49 on both sides. So x equals 5. Okay? So to remember, when you are finding the missing side length, you want to set up a proportion using corresponding sides. Okay, now on question 11, there is a lot to this. I tried to squeeze it onto the same slide, so I hope that you can see this okay. It tells us that triangle ABC and triangle XYZ are similar. So that means that they're the same shape, but they are different sizes. It also means that their side lengths are proportional. So right here, when it says complete the 3 pairs of proportions below, this says ratio of lengths of sides of triangle ABC. Okay, so AB, that is this side right here, and that is a 12. And AC, that is this side right here, and it is a 15. Okay? Now, when we're looking at AB, again, we know that's 12, and BC, that would be this one right here, and that is going to be 18. Okay, and on both of these, we can actually simplify these. 3 goes into 12 4 times, 3 goes into 15 5 times. So the simplified ratio would be 4/5. And on this one, 6 goes into 12 twice, 6 goes into 18 3 times. So the simplified ratio would be 2/3. And then AC, remember that was this side right here. So that is a 15 over BC, that's this side right here, which is 18. And then the way that they got to 5/6 is they simplified the 15/18 by dividing both the 15 and the 18 by 3. Okay, so 15/18 simplifies to 5/6. Okay, so let's go ahead and do the next part. Okay, so this gets a little bit tricky because they are simplifying here to get to the 4/5. And so we know that our side YZ is 20, right? We know side YZ is 20. And then the one that we're going to use to get to a 4 would be this side right here, because 16 over 20 is what simplifies to get to 4/5. Because if you divide 16 by 4, you get to 4, and 20 divided by 4 gets to 5. Okay, so 16/20 becomes 4/5. So that means that this one here was XY over YZ. Now the next one, 2/3, well, if the YZ is 3, and we know that our side YZ right here is 24, okay? Sorry, that's kind of small. So 24, and then to make 2/3, the one that we're going to have to put above 24, okay, and to make a 2/3, the one that we're going to have to put above 24 is 16, and that would be XY, okay? Also, as we compare up here, it says the ratio of the side lengths of triangle XYZ that correspond to the sides of triangle ABC in the ratio above. And so AB over AC, that was this side over this side, okay? So that's why we have the XY over XZ, because those are the ones that correspond. And then on the next one, AB over BC, I'm going to go ahead and erase this here. It's getting kind of cloudy. Okay, so AB over BC, so this is AB over BC, that is 12 over 18. And so the ones that correspond would be the XY over YZ. Okay, so let's go ahead and look at the next one. I'll go ahead and erase this here. So for the next one, we have XZ, which is this one right here, okay? And up top, notice it says AC over BC. So AC over BC, that's how we got our 15 over 18. So if we're doing the corresponding sides with the triangle XYZ, we would have XZ over YZ. So XZ over YZ, which would be 20 over 24. And then that would simplify to 5/6. Okay, and I think we forgot to simplify this one here. That would simplify to 2/3. Okay, so remember on questions like these, you are using what you found here, and then that's going to help you to be able to write your ratios for the second triangle. Okay, now on part B, it says choose the correct statement about the answers to part A. In each pair of proportions, the lengths of the sides of triangle ABC are not in the same ratio as the length of triangle XYZ. This is always true for similar triangles. That one's not true. In each pair of proportions, the lengths of triangle ABC are not the same ratio as the lengths of the sides of triangle XYZ. This is because the triangles are not right triangles, also not true. In each pair of proportions, the lengths of sides triangle ABC are the same ratio as the lengths of the sides triangle XYZ. This is because we compared the sides of triangle XYZ that correspond to the sides of triangle ABC, and the triangles are similar. So that one I think is definitely it. Let's look at the next one just to be sure. In each pair of proportions, the lengths of sides ABC are in the same ratio as the lengths of the sides of triangle XYZ. This is coincidence. We would usually not expect this from similar triangles that are not the same size, so not that one. So on part B, you would pick just this answer. Okay, now on these ones, you are finding the length of X, and we can see that our side X is right over here. Okay, so we're trying to find the length of this side. Now, in order to do this, what I'm going to do is I'm going to pull this shape apart. I hope that you can see that this shape is actually made up of two right triangles. Like here's a right triangle here, and then here's another right triangle here. So let's go ahead and just pull those right triangles apart. So if this is my right angle, I know that my base is 3 and my height is 5. Okay, and then for the other right triangle, right here we can see that our base is X. So that's the thing that we don't know. Here's the right angle. And then the height is 7.5. Okay, now these right triangles, they are similar figures. Okay, and because they are similar figures, that means that we know that their corresponding sides have a proportional relationship. So let's go ahead and set up a ratio for the smaller triangle, 5/3, and we can set that equal to 7.5 over x, and now to solve for the x, we just cross multiply. So 5 times x is 5x, 7.5 times 3, and that would be 22.5. And then from there, all we have to do is divide by 5. And that gives us 4.5. Okay? Okay, so let's go ahead and look at another one here. Again, we have two right triangles. I hope that you guys can see that here. We have this right triangle here, and then we have another right triangle here. So let's go ahead and pull those apart, because these two right triangles are similar figures. Here's my right angle. I know that the base of the smaller triangle is 2, the height is 3. I know the base of the bigger right triangle is 3, and I don't know the height, but because these are similar, I know that I can solve for x by setting up a proportion using the ratios of the corresponding sides. So I'm going to set up a ratio of 3/2, okay, so the height over the base. So that needs to be equal to the height, which we don't know, over the base. Okay, and then from there, we go ahead and cross multiply. 3 times 3 is 9, 2 times x is 2x, divide by 2, x equals 4.5. Okay, now as you go through these on your own, please make sure that you email me if you have any questions. When you email me, please send me a screenshot of the problem that you need help with so I can send you a video or a reply back with some help.